Okay, we're in section 30 of the notes now. This is the assignment on graphing lines. So we covered this section. We covered how we'd like you to graph a line. Of course, there's some variance on this. Some students want to do it one way and some do it another way. My encouragement is to use integer values. So we started plotting points. Given a relationship, we plot points. These are linear relationships. What do we notice about these linear relationships? They lined up, at least the points lined up. They're collinear, and we drew a line through those points. And we did some examples. How many examples did we do? Quite a few examples. We did talk about some special points over here, x-intercepts, y-intercepts. Hopefully that's well understood. Again, there's videos on the side if you need to watch those again, or just watch the entire lecture again if you have to. We went through examples. Again, these examples have videos on the side. If you want, you can watch these videos. If you want, you don't have to. I mean, bottom line, if you attended the lecture, you understood what was going on, there's really no need to watch those little embedded videos. However, they may help you if you get confused by some of these questions. All right, so we went through a bunch of questions. I realize that this graphing here, it's optional. What I mean by that, graphing a linear inequality is optional. I do believe you should pay attention to that. And of course, when I go through the homework set, I'll be reading through that and pay attention to that. My gut feeling though, I've never seen this in the web assignments, and I've never seen it on the exams. However, I will say this, a lot of things you're not going to see in your classes, but the expectations elsewhere might be higher. They might be expecting this over here. All right. So anyway, you got a lot of problems. I'm going to go to the homework now. I'm going to go to the whiteboard. Just give me 1 second to switch over. I'll get my whiteboard back. So the expectation now is that you've studied the material and you've done the homework. The homework talking about the embedded notes. What we're expecting from you now is that you pay attention to this and just reinforce what you're doing is correct. All right. So give me 1 second. I have to share the whiteboard with you. All right, you're seeing the whiteboard. The notes should be in your hand, as should your notebook with the work for the problems. All right, so we're in section 30 now. And we're doing the homework. Again, if you have not done what VEST should do, this is going to seem like it's going really fast for you. But if you've done it, it should be, I'm not going to say it didn't take you time to get through it, but it's easy once you learn how to do this. It should take you virtually no time at all to do the homework. Right? You're just reinforcing what we expect from you, though. So there's a relationship here between X and Y, and this is the relationship. Now, certainly what they want you to do is they want you to graph this. You should realize this is a linear relationship. We just went through a bunch of examples. So how do we graph a linear relationship? We come up with 2 points. And my recommendation is to use finger numbers, and see if you can figure it out. So I'm gonna pick on X. And what I mean by that, I'm gonna pick a value for X. So if X is 0, well, that's pretty easy to do because minus 3 times 0 is 0, and 0 plus 2 is 2. There's 1 point. Let's do another point. And some of what point you're going to choose. I like integers. I'm going to choose 1. And what would you get? Minus 3 times 1 is minus 3, and minus 3 plus 2 is minus 1. I have 2 points now. And what I'm going to do is I'm going to graph those 2 points. And the first point is 0, 2. That's right here. The other point is 1, minus 1. I have my 2 points. What am I going to do now? I'm going to draw a line through those 2 points. It's not artwork, but it's good enough. All right, number 1 is done. All right, if you want to look at the key, I didn't give you the graph, but I did give you the points. What points did I give you? I gave you the 0, 2, and I gave you the 1, minus 1. And we got the graph over here. We'll talk about using technology later to graph these lines out as well. All right, these are rough lines, rough picture. Let me go to number 2. Again, my hope is these are very simple questions for you. So what do you get? Y equals, this is a relationship now. It equals 3/5 of an X minus 2. What do they want to do? Graph it. How am I going to do that? I'm going to pick points. Again, I'm going to pick 0 for x because I believe it's easy. If it's not easy, I shouldn't be picking it. So what's 3/5 of 0? 0. What's 0 minus 2? Minus 2. Now, I'm not saying you can't pick 1, but I'll be honest with you, pick 1, you can get a fraction. So I'm looking for the first integer where I wouldn't get a fraction, and I would say the integer would be 5. Right? Why is that? 3/5 of 5 is 3, and 3 minus 2 is 1. I'm going to plot these 2 points and then draw a line through it. It's a linear relationship. What's 0 minus 2? 1, 2. What's the other point? 5. 1, 2, 3, 4, 5, and then up 1. What am I going to do now? Draw a line through those 2 points. That's a graph of that linear relationship. If you look at your key, by the way, I don't put a graph down. We'll talk about this later, about how to get a picture using a machine. So, and you should learn that, by the way. 0 minus 2 and 5, 1. Those are the points they've chose. Let's go to number 3. Again, these are linear relationship problems. X equals 3y. Well, same story. Make my table. And I'm going to select on the y now because I believe it's easier for me. And the number I'm going to select on y is actually 0. And why is that? 3 times 0 is 0. And that's what x is going to be. But what's the next number I would choose? And I'm choosing on the y. I'm going to say 1 for y. And why is that? 3 times 1 is easy. You get 3. All right, so I got my points. All I need is 2 points. I'm going to plot them. First point, 0, 0. It's at the origin. What's the next point? 3, comma, 1. That means 3 to the right, 1 up. What I'm going to do, draw a line through it. All right, my suggestion, look at the K. I know I don't have a graph down there. We'll talk about that later. But do they have these points down? They do. Both of those points are listed. All right, number 4, they're kind of switching it up on me now, and I'll write number 4 down for you. What do they want me to do? Find the x and y intercepts and then graph it. Let's write this down, and I'll go through that method with you. So to get an x-intercept, that's an abbreviation, all you have to do is set y equal to 0. Well, if you do that, what do you get? You would get 3x equals 6, or x equals 2. I'm going to put a table down for that, x and y. When x is 2, y would be 0. Now let's do the y-intercept. How do you do that? All you have to do is set x equal to 0. And what would you get over there? Minus 2y is equal to 6. Well, what's y? Y would be equal to minus 3. Let's write that down. Y is minus 3, x will be 0. I've got my 2 points, and I'll plot them down for you. Okay, ready? 2, 0. 1, 2. The other point, 0 minus 3. What's my suggestion? Draw a line through those 2 points. Not that it has to be perfect, but those lines go on forever. All right, let's look at the key. I want to make sure in the key we're looking at those points. And what point should we be looking at? The x-intercept 2, 0, and the y-intercept 0 minus 3. I want to point out, they wrote them down as an ordered pair, and I'll put this down now for you. And again, they wrote them as ordered pairs, so I'm writing that down for you. All right, let's keep going. And let's do number 5 now. All right, number 5 says graph. And these problems are very similar to what we've done in class. So what do you have? You have 2x, I'm sorry, it's not 2x, 2y minus 3 is equal to 5. Well, you know what? I'm looking at it, and I'm kind of thinking that it looked kind of odd to me. But I'm going to just maybe rearrange a little tiny bit. 2y is equal to 8, or y is equal to 4. All right, now someone says, how are you going to graph that? It's a linear relationship. And the graph of linear relationship, we're going to put down 2 points. Now, what do we know about this? We know y is always going to be 4. But this thing over here has no x in it. So x can be any number in the universe. What's a good number to pick? 0. That's 1 point. Y is always 4. Let's pick another point. What point are you going to pick? Any number you like. I'll be honest with you. It would be a good idea to pick an integer and a small one. I'm going to pick 1. So x can be any number you want. I'm picking integers. Let's graph this. And what do you get? 0, 4. 1, 2, 3, 4. Then what do you get? 1, 4. Let's draw the line through. What kind of line is that? That's a horizontal line. Y equals a number is a horizontal line, which is discussed in the lecture. All right. What points did they put down? I want to point out, looking at it, they put the point 0, 4 down, and they put the point 1, 4 down. Okay, let's go to number 5. And number 5, I'm sorry, I didn't mean to say 5. We just did 5. I'm going to go to 6. And sorry about that. What's 6? 2x minus 3 equals 5. This looks like almost an identical question. Let's go through it. 2x equals 8, or x equals 4. Graph it. What does that mean? It's a linear relationship, and a linear relationship is going to graph as a line. I'm going to pick x to be 4. I want to again emphasize to you, this has nothing to do with y, so y can be any number in the universe. I'm going to say 0 would be an easy choice. X will always be 4. Pick another element for another value for y. I'll say 1. Let's graph it. See what we get. First point, 4, 0. 1, 2, 3, 4. Next point, 4, 1. Let's draw a line through it. What kind of line is that? A vertical line. If x equals a number, we're going to get a vertical line. All right, let's keep going. Oh, by the way, again, look at the key. Make sure you've seen those points, and they are listed out. Could you have chose different ones? Of course you could have. All right, I'm just saying that typically most people pick very small numbers, and they try to stick with integers if they can. Let's put number 7 down. And number 7 is 3y minus 2x equals 6. And they say find the x and y intercepts and graph the function. Well, let's put this down in a table form, getting a little better at this. I'm going to write this over here, x-intercept. How do you do that? Set y equal to 0. Well, if you do that, what do you get? Minus 2x equals 6, or x equals minus 3. So I got a point over here, minus 3 comma 0. So what's my x-intercept? Minus 3 comma 0. Let's do the y-intercept. How do I get that? Set x to be equal to 0. What does this give me? 3y is equal to 6, or y is equal to 2. So I have this one down, which is 0 comma 2. 0, 2. I'm going to graph it. Again, graphs don't have to be looking great. Just, sort of like an abstraction. Let's see, minus 3, 0, right? 1, 2, 3. And then 0, 2. Draw my line through it. Call it a day. We're done. All right, look at the key. We'll talk about using technology later. And let's see if they got those points down. And this is number 7, right? Minus 3, 0. I'm seeing it, and I'm seeing 0, 2. And they're clearly identifying those as x and y intercepts. Let's go to number 8. And number 8 is 5y minus 4x equals 9. And what do they say? Graph it. A more challenging problem. What I've noticed, a lot of students spend a lot of time rewriting these guys over here. I have a gut feeling that I don't think rewriting it is a good idea. What I'm going to say is I'm looking for values that make it easy for me. My claim over here is that we typically, certainly we could write exceptions down, but I'm going to tell you they're going to be finger numbers, and they're going to be really easy finger numbers, right? Really easy finger numbers. I know it's difficult though. I really do. We want you to try though. Our gut feeling is if you start to try, you're going to get this. Right now, if you don't try and you keep saying, I can't do, you'll never be able to do it. So I'm going to start, picking values. And someone says, what value are you going to pick? I'm kind of looking at it. I know 5 and 4 are related to 9. So I'm going to look at it. And I'm going to say, well, if I chose x to be minus 1, I'm getting close. I'll put down why I'm getting close. It would be 5y plus 4 is equal to 9. Well, the only way I could satisfy that equation is if 5y plus 4 equals 9. Well, just by looking at it, I'm going to say y is 1. All right, that was pretty simple. That's a nice small finger number. Here's the deal. If you can find one ordered pair of finger numbers, there's an infinite number more waiting for you, right? An infinite number, right? I'm going to try another one. And let me erase my work over here. I'm kind of done with that. And I'm going to think again. What's the problem with thinking? Well, it might be hard, right? It might be hard to think. Kind of looking at it. And I'm going to try something. I'm going to try using 4 for x now. That's a big jump, isn't it? All right, a really big jump. And we'll talk about those jumps later. 5y minus 16 equals 9. Let me see if I can do that. 5y, and add 16 to both sides, 25. Well, gee whiz, 5 times what would 25 would be 5. All right, I'm going to talk about this. Again, if you can't follow this, that's fine. We're going to talk about this, and we're going to talk about this in a direction. So let me look at the x first. If you're at minus 1, you go to 4. You 1 up 5 units. I'm going to say the delta x is 5. Now let's look at the y's. If you're at 1 and you 1 up 5, you 1 up 4. That's a delta y. You should kind of see those numbers in the problem. What's nice about this? It's actually a counting problem. Let me go through that with you. Let me do the y's first. 1 to 5 is 4 up. If you go 4 more units up, you'd be at the number 9. We'll check it later. If you're at minus 1, you get to 4, it's 5 up. What's 5 up from 4? It's 9. I want to check this one for you. How do I do that? Well, both numbers are 9, so 5 times 9 is 45, minus 4 times 9 is 36. What's 45 minus 36? 9. It's going to work beautifully. All right? So what was the question? The question was to graph the line, given that relationship. Well, I'm going to put that down for you now. I'm going to circle the numbers I want to use. I like this ordered pair because it's easy. Minus 1, 1. That's done. The other point I find easy is 4, 5. Now 9, 9, too much counting. 1, 2, 3, 4, and I got to go up 5. All right, draw my line through it. And we're done. Okay. Let's do the next one, which is number 9. And what's number 9? It's 3x equals 9 minus 5y. And what they say is find the x and y intercepts and graph it. Well, let's do this. Let's do the x-intercept first. Set y equal to 0. Well, if you do that, you would get 3x equals 9. And that's pretty simple because x would have to be equal to 3 in that case. So what's the x-intercept going to be? 3, 0. A very nice, easy point. Let's do the y-intercept. They said find it. We're going to look for it. Set x equals 0. What do you get? Well, 3 times 0 is 0. 9 minus 5y. This is more difficult. 5y is equal to 9, or y is equal to 9/5. Let's write the point down. The point would be 0, 9/5. By the way, I'm not opposed to using that point. A lot of students have a tough time locating it. But I want to tell you that we got the x and the y-intercept. The x-intercept's very easy, but I want to get another easy point. I'm going to say 0, 9/5 for a lot of students is too difficult. All right? Let's put this down. And what do you get? You get 3, 0. Pretty easy to put that down. 1, 2, 3. I want to get another point. That's easy. Right? Another really simple point. All right. I'm looking at it. I want to get another simple point. Let me tell you this again. If I can find one easy point, there's an infinite number of easy points to find. All right. Kind of looking at it. And I'm going to, I don't know, maybe look at it and say, let me see. I'm going to try -2 for the x. I'll tell you in a moment how I'm getting these guys over here. What would that give me? I'm not saying it's working. -6 equals 9 minus 5y. If I subtract 9 from both sides, I would get -15 equals -5y. So y would have to be 3. All right, think about that delta change business for you, okay? I'm going to look at this over here. I'm going to push this over. I'm going to look at this over here. I hope you realize that delta y is really simple. It's going up by 3. What's a delta x? Well, if you're at 3 and you get to -2, you went down 5 units. You should see these numbers in the problem. I'm seeing the 5 or the -5, and I'm seeing the 3. I'm seeing them. All right. Now I'm going to plot those points. What's the other point I want to plot? I'll push this over a little tiny bit. -2. Whoops, sorry about that. And then 3 up. Okay, I'm going to draw the line through it. And let me think about that for a second. That's going to be a tough thing to draw through, isn't it? 2. Did I do that right? 2. Oh, I'm sorry. Yeah, -2, 3. I'm sorry. I did that right. -2, 3. I'm going to draw a line through that. Someone's going to say, I wonder if it went through the point that we said it should go through, which is 0 9/5. Well, 9/5 is 1 4/5. And this to me looks about 1 4/5. It's not a great picture, but it's close enough. All right, let's go to our key. Let's see if we've done a good job. And again, what I mean by a good job, I'm looking at the answer key. And I'm looking, did I get the x-intercept? Yep. Did I get the y-intercept? Yep. 2 easy points. I'm getting these 2 easy points over here. Yep, we did a good job. All right. Okay, I'm going to actually skip on 10 and 11. All right, I'm going to skip on them. I want to go to Sage. All right, I really want to go to Sage. Put this down. And again, 10 and 11 are optional. All right, let's go to the Sage code. I'm going to do another share. And I'm going to click on the Sage again. It's going to open up a web browser. I'm sure you're very familiar with this. We'll talk about a variety of software. I'm going to do Sage first. And again, we're just trying to get your feet wet in the programming skills. This is Python language. Again, I'm depending on other people's resources to run Sage on their computers. And we've done this many times, at least 30 times at this point. It's starting. And I'm going to do a new sheet. I'm going to do a Sage worksheet. It takes time though. Reset. Okay. Variables x, comma y. Whoops, I'm sorry about that. I'm going to put a comma in. These are 2 variables. Var for variable, x, comma y. And then I'm realizing that, this stuff might be really tough to type in. So I'm going to do a copy paste. Doesn't always work, by the way. Let's see what happens. Well, I drew a line. This is good news. All right. I'm going to say for the most part, a lot of students look and say, this is really complicated. Let's go back to Wolfram Alpha, okay? And one thing I like about Wolfram Alpha, it's a really simple problem to type in. And really we're trying to graph is, and look at all the code, just to graph in a line, x equals y. But you could do x equals y. And I'm going to say graph it. Okay. I like Wolfram Alpha. It's a great product. It graphs the line out. Now, what you could do here is type these other problems in. Let's do another one. Let's do problem number 8. And I'm going to type in 5y, I don't need the star, minus 4x equals 9. Let's hit return. Let's see how it does. It graphs the line. It graphs the line. You can see it right there. You know what? I want to do something a little more complicated. I'm going to see if number 10 can be done. I'm looking at it. What does it say? 3x plus 5y greater than 8. Shift. No, I'm sorry. I didn't mean to say that. Just return. My mind's in Sage. Wow. It actually graphed out the inequality. All right. Let's do the other one. See if I can do that. And again, just looking at my notes, I'm seeing 4y. This is problem number 11, by the way, minus 2x. How do you type that in? I'm going to say this way, less than or equal to 2. Let's see what happens. I graphed it in. Again, I'm having a tough time understanding what it's giving me, but it does give me a visualization of it. All right. Now, if you look at my notes, right, there's also graphs in the notes. I want to point out they're over here with the conventions we'd like you to follow. Here's the deal, though. I have never, ever seen these things on Essex County College exams. However, I want to point out inequality tends to be a lot more useful than equality in mathematics. You know, the ordering of objects, all right? And it's nice to know how to do that as well. Certainly finding the exact solution of equations is also very important, but there's pictures over here if you want to look at those, all right? That's about it. Thanks again.